Good morning and welcome to Pre-Algebra with Miss Betsy. Today our lesson is a little bit different than what we've done frequently in the past, in that I've just beginning and I already have my board behind me completely filled up with writing and figures. It's because what we're studying today is a introductory portion of geometry where we're finding the surface area of three-dimensional shapes. So I'm going to be tracking rather closely with my text today. If you're using the same book that I am, which is Pre-Algebra for Christian Schools, published by Bob Jones University Press, I'm using the first edition. I'm in chapter 12.5. It's entitled Surface Area. This is on page 417. You can follow right along because all we're going to be talking about is getting some basic definitions of three-dimensional figures and learning how to find surface area and what that means. But I am going to be tracking somewhat closely with our text today. Before we get started though, I've got a lame joke for you that my daughter told me last night, and I thought this one was pretty good. Can you tell me why it is that penguins don't fly? Well, it's because they are too short to be pilots. So let's go ahead and look and see what we have right now. One of the benefit of having video is that you can stop and copy, stop, restart as many times as you want to. But everything that I've pulled here, these are definitions that I've taken directly out of our textbook. So it's your responsibility to know and to understand all of the writing that's in there, and that's something that no teacher can do for you. This material is not necessarily so hard, but it does take time to learn. If it's taking me as your teacher over an hour to put together stuff and to prepare just one section lecture, and you have 3 of those a week, you know that you need to be spending a significant amount of time on your work if you want to be able to get all of this internalized and enough in your head that you don't get your thoughts totally confused when you do a test. First off, what we're talking about, these are called geometric solids. And a geometric solid is simply a three-dimensional object. Like this box here, a Jiffy Mix box here, this can of corn that I'm going to be using later to illustrate what we're doing for surface area. But the geometric solid has a specific definition. It's written right here. It's a shape whose points do not all lie in the same plane. And what makes that important? Well, that's what makes something three-dimensional. Two-dimensional object right here is just this piece of paper. All of the points on it lie in the same plane, so it's flat. There's no shape to it. You have to imagine shape. But as soon as you add a point in the object that is outside of that plane, that's what makes it look three-dimensional. So that's what makes my rectangular box here a geometric solid, because geometric solid because the points are not all in the same plane. You can shave off an infinite number of straight pieces here. So two-dimensional, three-dimensional. This is a geometric solid. We have what we call polyhedrons. Polyhedrons. And what this says, that this is a three-dimensional figure with flat faces that are shaped like polygons. Now, I have never been able to see things very well in 3 dimensions. I think God gives you the ability to see that, or it's just a challenge for you. It's hard for me to draw them as well. But I've tried to draw these, all of these pictures here. This is the best that I can do. You can look on your text, and you can see better three-dimensional drawings than these. But a polyhedron is a three-dimensional figure with flat faces that are shaped like polygons. What are polygons? They are quadrilaterals, they're trapezoids, they're parallelograms, they're triangles, they're octagons, all of these different multi-sided figure. We have 3 shapes here. A polyhedron is different from a cylinder. Cylinders are not polyhedrons because they don't have flat faces that are shaped like polygons. It's a curved face that unrolls, but it's not technically a polyhedron. So we have a triangular polyhedron, we have a cube, and we have this cylinder here. And we see that we've got a different definition for a cylinder. A cylinder is a three-dimensional figure that has shape to it. It has two parallel bases that are congruent circles. You have to remember your definition here. Congruent means that they're the same size and shape. Here's a cylinder. The bases, or what we might think of as the top and the bottom, are circles. Put it on end like this. We have a circle here. We have a circle here. They are congruent. Two parallel bases that are congruent circles. And this curved surface, you know, the curved shape here, this is what we call the lateral surface of a cylinder. So you have some more definitions there. Then, on this right side here, we have what we call prisms. And a lot of you are familiar with prisms because if you send a beam of white light through a prism, it will bend that beam of light, and that's where you get that rainbow look. Well, a prism is something that just has a technical math definition, and it says it's a polyhedron that has at least two faces which are congruent and parallel. Now you can have more than two faces that are congruent and parallel. Congruent is the same size and shape, and parallel is, you know what parallel is. It's as if they were railroad tracks or power lines. So this right here would be an example of a rectangular prism, just a box. Now think of a box. Has two parallel congruent bases. This can be the base, and this can be the base. It also has more, you know, with things that are parallel. It actually has three pairs of congruent faces on this box. A second type of prism that they've defined in our book today is called a triangular prism. And that would be like a wedge of cheese or an ultra-thick wedge of pizza. It's triangular. The bases are triangular. The top of it is a triangle. The bottom of it is a triangle. And no, when I said a piece of pizza, square off the piece of pizza so that you have an actual pointy triangle. Pointy triangle at the top, pointy triangle at the bottom, sides, and that's what a triangular prism is. And a cube is a special case of a prism, and a cube is like a dice or like a sugar cube or a square building block, and that's where you have six faces to a cube. You have six faces to this rectangle, top, bottom, back side, front side, sides on either end. You have the same six faces on a cube. All of these definitions here, you have to know them. You have to know what a rectangular prism is, you have to know a triangular cube, you have to know polyhedrons, you have to know cylinders. You don't necessarily have to be able to spit it out exactly, word for word here, but you have to have an understanding of what we mean when we talk about polygons, of what we mean when we're talking about congruent bases. A prism is a polyhedron that has at least two faces which are congruent and parallel. The two parallel faces are called bases. All they mean, I've used the term face several times thus far. The face is just a surface of your prism. So there are six faces on this rectangular prism here. Okay, now our book tells us that we're going to be talking about surface area. So let's see. We can find surface area of prisms. We can find surface area of cylinders, and that's the only actual calculation that we're going to be doing in this section. But what you have to be able to do to find the surface area of geometric solids is you have to be able to look at the picture that they're giving you and unwrap it so that it's two-dimensional. Now what do I mean? Let me show you. I'm going to go ahead and erase everything up here except this little picture of a rectangular prism. And I'm not going to draw a larger one because as bad as these objects are drawn, it still took me quite a while to get them drawn, so I'm not going to try and redo one. So if you turn to your text in page 418, you need to make sure that you understand this. This says the surface area of a prism is the sum of the area of all of its surfaces. So let's write this down. If you don't understand this, you cannot find surface area. Which stands to reason that if you don't know what you're looking for, you certainly can't find it. It's the sum of the areas of all of the surfaces. See if I can say it a little bit more clearly. The sum of the area of all of its surfaces. Sum of the areas of all of these surfaces. So we're working with this rectangular prism here, and we want to find its surface area. They give us an example in our book that I'm going to go ahead and copy those definite dimensions exactly. 9 inch, 4 inch, and 3 inch. Now my drawing is not perfect, but it is exactly understandable as it's written. It may not be straight and perfect, but this is the type of drawing that they're going to give you, and they say, okay, how many surfaces do I have here and what are the dimensions? Let me go ahead and unwrap this for you. Here is my rectangular prism. The longest dimension right here is what's 9 inches. The dimension that's going back this way, this longer side, that's 4 inches. Then it's 3 inches tall. What does this look like when you unwrap it? In other words, how many surfaces does it have? Well, a rectangle has 6 surfaces. Okay, let me hold this right up here. And this is how they have this written, this drawn in your book. They say, okay, this right here, we actually have 6 separate surfaces. 2 big bottom, the 2 big bases, you have these 2 smaller ones. You have the 2 longer sides of the box. So that's what you're going to have to be using to figure out the surface area of this. So let me just go ahead and sketch right here this unwrapped box, or opened up, made into 2 dimensions, rectangular prism. And I'm sketching in here what they actually have written in your book. As I continue to demonstrate to you, there's a reason that I do not teach art. You can see that this is larger than the side. Let me exaggerate that maybe a little bit more. This is what our rectangular prism looks like when you unwrap it. The first piece right here, this is the large bottom. So it's 4 inches by 9 inches. This second piece right here, this is that side of the short side of the box. What are the dimensions of that? Well, it's 3 inches high, and it's still 9 inches wide, isn't it? Well, what about right here? This dimension right here, it's the same as this 4. So it's the 9 by 4. So you still have 4 inches on this dimension. So you have a 3 inch by 4 inch rectangle. You have a 3 inch by 9 inch rectangle. You have a 4 inch by 9 inch rectangle. And you have 2 of each of those rectangles. Okay, everyone tracking with me? Some of you will see this real easily. Some of you, I'm sorry, you just won't. You're going to have to practice it. You're going to have to look at it. Going to have to work with it until it makes sense to you. Let me go ahead and label my sketch up here a little bit more for you according to what it looks like with the book, for those of you who do not have a book to track along with. This is the top of my box, or the top of this rectangle here, and that's what they call a base. This one right here is the back of this rectangular solid, of this rectangular prism. This right here is the bottom. That's what we're calling the base. This right here is the front of the box. And these are sides. Okay, look at that, see if it makes sense. Go ahead and go back to my cut apart box that I have right here. Here's my box. This is the shape that we have. This is how it's been sketched on the board. We open it up. Here's the top of the box. Next is that back side of the box. Next, down here, the bottom of the box and the front. Top, back, bottom, front, and the 2 sides of this rectangular prism. Now, how did we say that we find the surface area? The surface area is the sum of the areas of all of the surfaces. We have 6 separate areas here, but we have 3 pairs of areas that are the same. So let's go ahead and figure out how we're going to do that. I'm going to go ahead and erase this definition here so that I can keep my work all on this one board. How are we going to find the area of a base? Well, area is length times width. What is the area of one of these bases? The length times the width. The area is 9 times 4, or 36 square inches. 4 times 9 is 36, 36 square inches. Area of one base. How about area of the back? Let's see how they label it. Well, they say area of the front. How are we going to find the area of the front here? It's another rectangle, isn't it? This area is another rectangle, length times width. This is also a 3 here. Length times width, 4 times 3. Area is therefore 12 square inches. Now, so we have the back and the front are the same, the top and the bottom of the side, same, and then we have the sides. How are we going to find the area of the side? Area of the side, once again, another rectangle. Area is length times width. Area is, okay, I'm not going to redo this lecture. Said area of the front, I was actually giving you the area of the side when I said 4 times 3. Rewind here, and let's say that we are finding, instead of the area of the front, this is the area of the side. Labeled side, the length is 4, the width is 3. Everybody's all right with me here? Now, since we've already calculated the area of the side, we have to find, how about the area of the front? It's another rectangle. So of course the area is length times width. The area of the front, 3 and 9. Length is 9, width is 3, which means that our area is 27 square inches. Okay. See, there's a little bit of work involved in here. First you have to figure out, what are these sides that you're looking at? I mean, what are the faces? What are their dimensions? How do you find the area of all of the different faces to your object? And then total them up to come up with the total surface area. So your book tells us that the surface area is the area of the bases plus the area of the sides plus the area of the front and back. Makes perfect sense, doesn't it? Area of the bases, area of the front, area of the back, area of the sides. So you're going to have to add all of these values together. What's the area of the base is going to be? Well, it's going to be twice. So I'm going to say 2 times the area of the base plus 2 times the area of the side plus 2 times the area of the front. And how can that be? Well, front and back are the same. So what's our surface area going to be? The area of one base is 36. So it's 2 times 36 plus the area of the side is 2 times 12 plus twice the area of the front, and boy, that's smeared, plus twice the area of the front, which is 27. Go ahead and look at this, make sure you agree. Bases, top base and bottom base, 36 inches, twice. Sides, 3 times 4, 12 inches, twice. Front, length times width, 3 times 9 is 27, twice. That's what our total surface area is going to be. area is 72 plus 24 plus 54, I hope. Area is, carry 1, 150 square inches. So make sure that you understand when you're doing these surface area problems, it is totally different animal from finding the area of just a flat surface. Flat surface is just like length times width, or the area of a triangle is 1/2 the base times the height, or the area of a parallelogram is also length times width. But with surface area, you have to find the area of every single side of that object. And you're going to have to learn to look at this and say, you don't have to draw a picture where you've unfolded it, but you have to be able to look and say, okay, I've got the bottom here, it's 4 times 9, that's going to be the same as the top. I've got the front here, which is 3 times 9, that's the same as the back. And then I have this side here, which is 4 times 3, and I have 2 of those sides. You have to practice these. Like I said, some of them will come really easy to some of you. Others of you, it will be a challenge, but you can do this. You just have to be willing to invest the time in it. This is the surface area of a prism. Now, let's talk about how we find the surface area of a cylinder. Because a cylinder is a little bit of a different creature altogether. And in all actuality, in all honesty, cylinders are the easiest ones. For those of us who are challenged in seeing in 3 dimensions, like I am, it's very difficult for me to go from 2 dimensions to 3 dimensions visually. But cylinders are easy. How are we going to find the surface area of a cylinder? Remember, I said a cylinder had the bases, which were congruent circles, and this lateral surface, which is what wraps around it. Got a can of corn here. I've cut the label, so what's going to happen when I unroll this surface area, this lateral surface here that's a curved surface, is nothing more than a big old rectangle. Isn't that nice? So the surface area of a cylinder, if you would actually unwrap that, well, your sketch is going to be something like this. Because I roll this up again, and I have a circle on the top and a circle on the bottom. So that's how you find the surface area of a cylinder. So let's sketch the surface area of a cylinder and find its area. And they're going to give you the dimensions. So this example here, specific one, is on page 419 in our text. Let's see. We have a radius that's given to us right here of 3 inches. What they've done is they've taken apart a cylinder for us, and they've drawn this over here. Let me draw this on this side. We have our circle, the top. We have our base here. Circle at the top, circle at the bottom. They tell us that the height is 9 inches. And they tell us that the radius of this circle is 3 inches. Remember, radius is half the diameter. And we're going to have to find the area of the base. That's an easy thing for us to do. Do you remember what the definition is to find the area of a circle? Well, the area of a circle is pi r squared. Over here, area of circle, pi times the radius squared. So the area of this figure is going to be 3.14 times 3 squared. Unless they tell you otherwise, you're going to use 3.14 as an approximation for the area of pi, for the value for pi. So it's approximately equal to 3.14 times 9. So your area of the circle is approximately 28.26 inches. Now, we know what the width of this rectangle is, okay, which is actually going to be sort of like the height of the cylinder. But what is the length? How are we going to know what the length is? Well, let's think about this. Let me come back to my picture here. I cut the label off of the can. When you unroll that label, you have a rectangle that we have here. We know that since the can is 9 inches tall, that this has to be 9. But how in the world are we going to figure out what the length of this thing is? There's nothing measured there. That's where the three-dimensional comes in. Look at our label this way. This right here, what's this called? This is the circumference of the circle, isn't it? But when you cut that ring and you unroll it into a two-dimensional rectangle, the length of it is actually the circumference of the circle. That's really important. Got to remember, it's important enough that you better write it down in your notes. This length is the circumference of the cylinder. Okay, how do you find circumference? We found an area of a circle. The circumference of a circle is the definition that you should have already memorized. Circumference is twice the diameter. I'm sorry, I didn't mean twice the diameter. Circumference is pi times the diameter. Or we also learned that circumference, if we are given the radius of a circle, that the circumference was 2 times pi times the radius. We're given the radius, so the circumference of the circle then is 6 times 3.14, 18.84 inches. Now once again, it's approximately, because we're saying that pi is equal to 3.14. Let me check my mental arithmetic there. Yes. The circumference of a circle, 2 pi r. The radius of the circle is 3. Double that is where I came up with 6. 3.14 is the approximate value of pi. You multiply that together and you have 18.84. So why was that so important to figure out the circumference of a circle? Because we needed our other dimension. The length of our rectangle here, 18.84 0.84 inches. Okay, everyone all right with that? So now, what's our surface area of this cylinder going to be? The surface area is twice the area of the circle, plus the area of the lateral surface. Look at this and make sure you understand what's going on. The top and bottom of the can, so we have to find the area of that, so it's 2 times the area of the circle because the top and bottom is the same. Then we have the area of the lateral surface. What that lateral surface is the unwrapped label. So you have a rectangle here. What's the area of the circle? We've already calculated it out. So the area of the circle is approximately equal to 2 times 28.26. What is the surface area of this rectangle? What's the area of this rectangle? It's length times width. Plus 18.84 times 9. Go ahead and use your calculator to come up with these values. And you're going to have, I'm not even going to bother doing them at this point. You have 56.52 plus 169.56. So the surface area equals approximately 226.08, that's interesting, marker won't go there, 226.08 square inches. Do not fail to remember that units of area are always square units. 226.08 square inches. Okay? Go back through that. Now you saw that it took a while, quite a while in this lecture, as a matter of fact, to go through definitions, to explain how we go from 3 dimensions into 2 dimensions, and to explain what surface area is. This is not a section of homework this week where you're going to be able to sit down and do your work in an hour, because you have not only this section, but 2 more where we're finding area and volume of prisms and things. So go ahead, hang in there. I know we're getting close to the end of the year, but I know you can do it, and I'll see you next time.